Okay, we'd like to take out the greatest common factor from the two terms of this polynomial. So this is an effective way to factor a given expression. The way this works is you look at every term and you ask what is the most that can come out of both pieces. So you could start with the constants or the variables, it really does not matter, but I'll start with the constants. I have 80 and 20. So if I'm going to construct off to the side my greatest common factor, the most I could take out is going to be 20 from both pieces. And all right, now I have to focus on the variables. I have an x to the fifth and an x to the fourth, so I know I can take out some amount of x's, but the most that you can take out from both pieces is going to be x to the fourth power. You can't take out an x to the fifth because there's not enough in the second piece, but I think that this is the greatest common factor. So what I do is, if I just copy down the problem again, I'm just trying to rewrite this in a way that is factored. The way I do it is, I write down my greatest common factor of 20x to the fourth, and I set up some parentheses. Inside the parentheses, I place whatever is necessary so that when I distribute the 20x to the fourth inside the parentheses, it takes me back to my original answer. So here's what I mean. In this very first spot, I want to place something so that when I multiply this in, I get 80x to the fifth. So again, if you start with just the numbers, I have 20, I want to get 80, therefore I have to have a 4. Now if I deal with the variables, the x's, all right, I have an x to the fourth, so therefore if I have an x to the first, that's going to give me my x to the fifth, and that's perfect for this first part. 20x to the fourth multiplied into here definitely gives me 80x to the fifth. So to complete this problem, I just need to place something over here so that when I distribute my 20x to the fourth, I end up with this, a negative 20x to the fourth. So it kind of seems like 1 should do the trick, but I'll just make it negative 1. That does it. I mean, it's perfect. If I check my answer, I know this to here gives me my 80x to the fifth, this to here gives me my negative 20x to the fourth, and this is what it looks like to factor using the greatest common factor. If you are unable to come up with 20x to the fourth is the greatest common factor, you can really start this problem just by, you make a guess, right? You could say, well, maybe I think the greatest common factor is, so you could say, maybe it's 5x squared. You really could start here, and it'll take you in the right direction. It just might take you a little bit longer to get to your final answer. Here's what I mean. If you do 80x to the fifth minus 20x to the fourth, and you think you can only factor out, let's say, a 5x squared, you're still left with deciding what goes inside the parentheses. All right, so if I want to get an 80x to the fifth and I have a 5, I would have to put a 16. And if I want to have an x to the fifth and I only have an x squared, I would need an x cubed. And then we would just complete this process for my negative 20x to the fourth. Okay, it's got to be negative. And if I want 20 and I have 5, there has to be 4 left over. And if I want an x to the fourth and I have an x squared, I would need another x squared to do so. So at this point you can say, all right, this can't be the greatest common factor. And the reason is, you would look at this piece and you'd say, well, there's still stuff that can come out. You would say, oh, right, well, I know I could take maybe a 4 and a 4 out. And, oh, well, maybe I can take out an x squared from this, and maybe I'll take out an x squared from that, again, getting you closer to the final answer. So as you look at more complicated problems, make a guess as to what you think the greatest common factor is and factor it out. And then look at what you have left over. If you're like, oh, well, there's more things I could take out, just start removing them. Eventually, you will get to your final answer of this, 20x to the fourth times 4x minus 1. All right, so again, really focusing on a greatest common factor idea, I want to factor 5x times 2x plus 7 minus 7 times 2x plus 7. If I want to factor this using the greatest common factor, and I look at both of my pieces, I notice that they both have a 2x plus 7 in it. And that's actually the most that I can take out of both pieces. So your greatest common factor can actually be pretty complicated. I'll write it with parentheses, but in this case it's 2x plus 7. It doesn't just have to be one term. It could actually be something separated by a plus or a minus sign, as long as you maybe put some parentheses around it just to indicate that you're eventually going to multiply. But let's see what that looks like here. So I have my original expression, and I'm factoring out 2x plus 7. And again, I just set up parentheses and ask myself, well, what is left over after I take out 2x plus 7? The answer turns out to be pretty simple. It would just be 5x, and then it would just be negative 7, this minus 7 at the very end. So I'm just going to jot those two things down. I have 5x, I have minus 7. I know this works because when I distribute this entire thing to 5x, I get 5x times 2x plus 7. I won't even multiply it any further. I'll leave it just like that. If I take this and I multiply it to this negative 7, again, I'm just placing it after the negative 7. So it kind of look a little confusing at the beginning, but this is actually the final answer. This was my greatest common factor. I look at my two remaining terms and there's nothing left to take out, and that is it. So here I still use the greatest common factor to factor apart my original expression. And for the final example, what I'm going to do is combine the ideas from the first and second example into example number 3. So let's see, I have 21x cubed plus 7x squared plus 15x plus 5. My ultimate goal here is to factor this expression, but we're going to use something called the factor by grouping method. So we're still going to use a greatest common factor, but what we're going to do is we're going to use it on just the first two terms and just the last two terms and see how that helps us completely factor this expression. So, just being a little bit more careful. So we have 21x cubed plus 7x squared, and then we also have this plus 15x plus 5. So the term factor by grouping means you're going to group the terms that appear within your expression. So I'm really going to think of 21x cubed plus 7x as one thing, and then 15x plus 5 as another, so that they're like two separate pieces. So now I'm going to have like two different greatest common factors that I'm going to deal with. So like here on the left, there's going to be a greatest common factor for the first two terms, and on the right, there's going to be a greatest common factor as well, but it's probably just going to be different than the first one. So if we start with 21x cubed, the greatest common factor is going to be, 7. That can be removed from both 21 and 7, and x squared. Whereas the greatest common factor on 15x plus 5 is actually this 5. You can't even take out a variable. So again, using just the greatest common factor on the first two terms and the last two terms, let's try to factor just those pieces and see what happens. So what I'll do is I'll write down the greatest common factor, set up a set of parentheses, and then put plus my other greatest common factor and set up parentheses again, placing inside the parentheses what I would need to multiply back to the original expression. All right, so we have 7x squared that we took out of a 21x cubed. I know there's going to be a 3 that is left over and an x. And also, since I have a plus 7x squared, I'm going to put a plus 1 at the very end. I did it. If I distribute the 7x squared back into just those two terms, it would take me back to the first two terms of my original expression. So doing the very same thing for the last two pieces, I get a 3x, and well, what do you know? I get a plus 1. So it's like step 1 was group the terms, come up with two separate greatest common factors, and remove them. Now I have something that looks a lot like something in example 2, where I have a 3x plus 1, I have another 3x plus 1. I could call that the greatest common factor of this line, so I think that's exactly what I'm going to do. I'm going to say, well, now I have this new greatest common factor. It's 3x plus 1. Therefore, I can continue. I can say, all right, I'll put 3x plus 1, set up another set of parentheses, and place in what should be left over. And just like last time, it's now going to be the 7x squared and this plus 5. So I'll put 7x squared plus 5, and that's it. I took something that was 4 separate terms being added together, and now I've broken it up into the product of 2 pieces.